If you've ever deleted a column and suddenly your sheet fills with #ref, you're not alone. That error is Excel's way of saying, I can't find what this formula used to point to. The good news is you can usually fix it fast, and you can prevent it next time. The key is understanding what broke: a cell reference, a range, a named range, or even a lookup table. Once you know the type of reference, the repair is straightforward. You'll learn a simple triage process. Identify where the break started, figure out what was deleted, then rebuild the reference in a safer way. We'll also cover common traps, like VLOOKUP table arrays, chart series, and pivot sources that quietly depend on those columns. By the end, you'll have a repeatable checklist you can use anytime #ref appears after structural changes. No guesswork, just a clean path back to working formulas. Next step. Let's decode what #ref actually means. Excel formulas store addresses like A2 or ranges like A2 to A20. When you delete a column, Excel tries to shift references to keep formulas pointing at the same data. That works when the reference cells still exist. But if the referenced column is removed, the address becomes invalid. Excel can't point to nothing, so it shows #ref. You'll see it inside formulas too, like equals sum #ref D10. That's a clue that part of a range was deleted. Another clue is when a lookup formula still runs, but the return column is gone, so the return reference becomes #ref. Also, #ref can come from objects, not just cells. Charts, conditional formatting rules, data validation lists, and pivot sources can all reference deleted columns. So the first step is not to panic. Treat #ref as a precise message. Something you reference no longer exists, and Excel is asking you to reconnect it. Next step. Before fixing anything, do a quick triage so you don't chase symptoms. Start by finding the first place the error appears. Often one deleted column breaks a source formula, and then many dependent cells inherit the error. If you fix the source, the rest clears automatically. Next, check whether the error is isolated to one formula type, like lookups, or spread across totals, charts, and reports. That tells you if the deleted column was part of a shared dataset. Then confirm what changed. Did you delete the column, clear its contents, or hide it? Only deletion breaks references like this. If you can, use undo immediately. Undo is the cleanest fix because it restores the original structure. If undo isn't available, you'll rebuild. Finally, decide if the deleted column should come back or if formulas should be updated to a new source. Next step. Now, the quickest repair method: restore the missing column. If the column was deleted by mistake, reinserting a column in the same position can bring many formulas back to life, because Excel references are positional. But there's a catch. Reinserting a blank column only helps if the formulas referenced that column location, not specific values that are now gone. If you also lost the data that used to be there, you still need to restore the values from a backup, version history, or another copy of the file. A practical approach is to insert the column where it was, then paste the correct header and data back in. Once the structure matches, many #ref errors disappear instantly. If only some formulas recover, that's a sign the formulas were referencing a specific range that changed shape, like a table array in a lookup. In that case, restoring the column gets you halfway, and you'll fine-tune the formulas next. Next step. If you can't or shouldn't restore the column, you'll repair the formulas directly. Start with one #ref cell that represents the pattern. Read the formula and locate the broken part. Excel usually shows #ref exactly where the missing reference is. Replace that segment with the correct new reference. Then copy the corrected formula to the rest of the range. If you have many errors, use find to search for #ref inside formulas. That helps you spot repeated breakpoints, like a missing column in multiple sheets. Keep your edits controlled. Fix one formula family at a time. Then check if dependent cells recover. Also watch for mixed references, like $A or $A2, because deleting columns can shift relative references in ways that look correct but point to the wrong field. When in doubt, validate by checking a few known rows and confirming the numbers match expectations. Accuracy beats speed here. Next step. Lookups deserve special attention because deleting columns breaks them in predictable ways. With VLOOKUP, the most common failure is that the table array used to include the deleted column. If the table array becomes invalid, you'll see #ref. Even if the table array still exists, the column index might now point to the wrong field, which is worse because it returns a wrong value without an error. With index and match, you can get #ref if the return range was deleted. With XLOOKUP, #ref happens when either the lookup array or return array was removed. The fix is to redefine the lookup range and return range so they point to the correct columns. If possible, convert your dataset into an Excel table and reference columns by name. That way, if columns move, your formulas stay readable and more resilient. The goal is not just to remove the error, but to prevent silent wrong results. Next step. Another common source of #ref after deleting columns is charts and other linked objects. A chart series is basically a formula that points to a range for values and labels. Delete a referenced column, and the series can turn into #ref, leaving blank charts or missing lines. The same idea applies to sparklines and conditional formatting rules that reference a range. The fix is to edit the object's source range and point it to the new correct columns. If you have multiple charts built from the same dataset, fix one carefully, then reuse that structure. For conditional formatting, check rules that use formulas, because they can hide #ref until you open the rule manager. Data validation lists can also break if they reference a deleted column, causing drop-downs to stop working. These issues often don't show up in a simple error scan, so it's worth checking your key visuals and controls after structural edits. Next step. Named ranges are another hidden dependency. A named range might refer to a column like equals sheet 1 $D, or a specific block like equals sheet 1 $D 200. If you delete that column, the name can become #ref, and every formula using that name breaks at once. That's painful, but it also makes troubleshooting easier because one fix can restore many formulas. Open the Name Manager and look for names that show #ref in the refers to field. Then redefine them to the correct new range. If your workbook uses structured names for reports, like sales data or lookup table, this step is critical. Also watch for names used in drop-down lists, charts, and pivot sources. A good practice is to name ranges that are meant to move, but base them on stable anchors like an Excel table column. That way, the name follows the data, even when you rearrange columns. Next step. Let's talk about Excel tables, because they're one of the best defenses against broken references. When your data is in a table, formulas can refer to columns by header name, like sales amount. If you insert or delete other columns, those structured references usually remain intact, because they're semantic, not positional. Tables also expand automatically as you add rows, which reduces the need for fragile fixed ranges like A2 to A1000. If you're repairing a workbook with lots of #ref, consider whether the underlying dataset should be converted into a table. Then update key formulas to structured references. This is especially helpful for lookups, sums, and calculated columns. There are trade-offs. Some older formulas and external links can behave differently with tables, and you need consistent headers. But for most reporting and analysis workbooks, tables make your model more stable and easier to maintain. Next step. Sometimes the #ref isn't in a visible formula cell at all. It can be in a pivot table source, a query output, or a connection that expects a specific column layout. If you delete columns inside the source range of a pivot table, the pivot might still refresh but lose fields, or it may throw errors depending on how it's built. The fix is to update the pivot source to the correct range, ideally a table, then refresh. For Power Query outputs, deleting columns in the destination sheet can break downstream formulas referencing that output. In that case, you either restore the expected output columns or update formulas to the new schema. The big idea is that data model elements rely on consistent field names and locations. After structural changes, do a controlled refresh cycle. Update sources, refresh queries, refresh pivots, then check dependent formulas. That order prevents chasing errors that are only temporary. Next step. When you're fixing a lot of #strip errors, you need a safe workflow to avoid creating new problems. First, make a copy of the file or save a new version. Then, work in passes. Pass 1, restore structure if possible, like reinserting columns or restoring headers. Pass 2, fix core formulas that feed many cells, like lookup columns or key totals. Pass 3, fix secondary items like charts, conditional formatting, and validation lists. As you go, keep an eye out for fixed but wrong results. Those happen when a reference shifts to the wrong column but still points to a valid cell. A quick spot check helps. Pick a few rows and manually verify expected outputs. If the workbook is shared, document what you changed, especially if you replaced positional references with table references. That makes future maintenance easier and reduces the chance of the same break happening again. Next step. Prevention comes down to how you design your workbook. If you know columns might be removed, avoid formulas that depend on a specific column number. That's the big weakness of VLOOKUP with a hard-coded index. Prefer XLOOKUP or index and match, where the return range is explicit. Use tables so your formulas reference named fields. Keep raw data and reporting separate. One sheet for the dataset, another for calculations and dashboards. That way, you're less likely to delete a data column that a report depends on. Also consider adding a simple schema row at the top. Stable headers that never change, even if you add helper columns elsewhere. Finally, when you must delete columns, do it intentionally. Check what depends on them first, then delete, then run your validation checks. A little structure up front saves hours of cleanup later. Next step. Let's wrap this into a simple mental model you can reuse. Ref is not mysterious, it's a missing address. First, decide if you can restore the deleted column. If yes, restore structure and data, and many errors vanish. If no, fix the source formulas by replacing the broken reference with the new correct range. Then handle special cases. Lookups, named ranges, charts, conditional formatting, and pivots. After that, do a quick accuracy check to catch shifted references that don't throw errors. And finally, upgrade your workbook so it's harder to break. Tables, named fields, and lookup methods that don't rely on column position. If you want one rule to remember, it's this: design formulas to describe what you mean, not where it happens to be located. If this helped, subscribe for more Excel troubleshooting that focuses on practical fixes. And in the comments, tell me which breaks more often for you, lookups or charts. Small tweaks compound into massive performance gains. Subscribe to catch the next workflow optimization.